Good morning, geometry class. I'm glad that you're tuned in here, and I am praying that everyone is tuning in today. We're getting ready to embark on the last two sections that we're going to cover this school year, so yay. But these are not things that you can guess about. I'm doing keywords again for you, just to get your mind thinking and along the lines of what you're doing today. I'm teaching part of this lesson because it's a lot to get your head around. On Tuesday, I'm finishing the lesson, and that's when you will finish up your assignment 65. Wednesday next week is not a take a break day because you have your break off for Memorial Day weekend, which I hope that you enjoy. So we'll start section 2 on Wednesday and finish it on Thursday. On Friday next week, you're going to have a review for a quiz on the first two sections, and your quiz will be on June 1st. The second, third, and fourth, and fifth, we're going to be doing review things to help you to get ready for your last test. So we're going to take a long time to review. Now, our final exam day is scheduled for June 9th, but you do not have a final exam. You have a last test on June 9th. And that last test is worth 1.5 times a regular test because it will be over all of Chapter 11 and the two sections of Chapter 12 that we're planning on doing. So your last test will be on Tuesday, June 9th, because all of the even days are taking their finals, all of the even periods are taking their finals on that day. That means that it is not ethical for me to give you your test early. So I will be getting up in the wee hours of the morning on June 9th to provide you with your last test. You will take it on June 9th and you will submit it on June 9th. Okay, so that's how that will go. But right now we're jumping into trigonometric ratios. So let's just get your brain going, okay? I have a joke. Okay, here's a joke for you. How many apples grow on a tree? All of them. Bump. Okay, so hopefully there was a little chuckle that happened there. Once you finally got that, all the apples grow on a tree. So we've got your brain going now, so that's good. The thing that we're going to talk about today, trigonometric ratios, we see the word ratio in it, and ratio is a friendly word because we know about ratios. Ratios are just fractions. So basically what happens is that when you have a right triangle, okay, when you have a right triangle, you have ratios, special ratios that compare the sides of that right triangle. That's what all these words are saying. So you have special ratios, and we're going to be talking about those special ratios. You do not have to write this slide word for word. Okay, now these two triangles are similar. Okay, take my word for it. If you divided out all the sides, you'd find the same ratio, and you would find that the ratio 8 to 15 and 4 to 7.5 would give you the same ratio. This is the scale factor here is 8 to 4, which is 2 to 1. So we have those ratios are the same. So in similar triangles, the comparison of the two sides in the same triangle, like 8 and 15 and 4 and 7.5, give you the same answer. Okay, so not only are these ratios similar so that the scale factor is 2 to 1, once we know that they're similar triangles, the ratios to the sides that look like each other are the same, and they are called the trigonometric ratios. What I want you to write down as your keyword is trig, because trig is how we usually shorten that. So if anybody's talking about the trig ratios, they're just shortening trigonometric so that you know what you're saying. So write down the word trig. That's one of your 4 keywords that show me that you listened very well to this video. Okay, so trig ratios is what we're going to be taking a look at. There are three basic trig ratios, three basic trigonometric ratios that are ratios of the sides of the triangles. They are called sine and cosine and tangent. Some of you may have noticed on a calculator that there are words on there that represent the three basic trigonometric ratios, and those look like sin and cos and tan. Now we are not using the calculator today, okay? We are not using the calculator today. Monday, when I finish the lesson, we'll be using the calculator. So at the end of today, I would suggest that you go through and do part of the assignment number 65. And yes, 64 is not on there. Some of you might have noticed that there is an assignment 64 on the previous assignment sheet, and it says optional or something along that, or extra credit. So if you were to do and take a picture of assignment 64 from the last chapter, if you have extra time, especially next week or whatever, I'll take that and double one of your other assignments and give you credit for 64 as long as you do it and do it well. But 65 is the next one that is due that you have to do, and it's on section 12.1. So after you've finished watching today's, I would go through and do part of it, and I'll explain what part later. Sine and cosine and tangent are abbreviated by the first three letters of those words, which is very interesting because why just chop off one letter? It just makes it easier to follow, and so that's what we do. Sine of A, cosine of A, and tangent of A. Each one of them talk about a special ratio on the sides of a triangle. The sine refers to the side opposite of angle A divided by the hypotenuse of the triangle. So if there's numbers in here, it's the side opposite of A. Okay, you've got angle A, opposite side is across from it. The hypotenuse of a right triangle, we know where that always falls. It's the one that's opposite of the right angle. So the sine of A is the side opposite divided by the hypotenuse. These are sides. These are not angles. So we have the sine of the angle is the ratio of the sides, the opposite over the hypotenuse. The cosine is defined as the side adjacent to A divided by the hypotenuse. The adjacent side is the one that makes up the angle A but is not the hypotenuse, if that makes sense. So we have three sides. We have an opposite side, we have an adjacent side, and we have a hypotenuse. And the tangent is defined as the side opposite divided by the side adjacent. Okay, well, let's make that so that you can write it down and not have so much to write. If I label these sides, now traditionally the side length is the lowercase letter that is opposite of the uppercase letter. So we have little a is the length of this side, little b is the length of this side, and little c is the length of this side. So you absolutely need to write this down. So for sine here, the opposite of A is A, and the hypotenuse is C. So whatever numbers were there, A over C would be your ratio for the sine of A. For the cosine of A, the adjacent side is B, the hypotenuse is C, so it would be B over C. For the tangent, the opposite is A, and the adjacent is B, so it would be A over B. Now notice that I'm very careful to say the sine of A, cosine of A, tangent of A. That's based on this angle. You can get a sine or a cosine or a tangent based on either one of the acute angles of a right triangle. we're not dealing with the sine or the cosine or the tangent of the right angle. Okay, because the hypotenuse and the opposite would be the same thing, so we can't do that. So for when we talk about the trig ratios, we have to do this. Now your second keyword is sine. I want you to write down that your second keyword is sine. Your first one was trig. The second one is sine. And then our sine is always going to be the opposite over the hypotenuse. Now, if we're looking at basing everything off of b, okay, the sine of b and the cosine of b and the tangent of b, in this case, our words change around with this. Sine of b is the side opposite of b over the hypotenuse. So the side opposite of b is b and the hypotenuse is c. So the sine of b would be b over c. The cosine adjacent to b would be a over c. And the tangent would be b over c. So it matters very much whether you're taking the sine of a or the sine of b, okay? Because it's always opposite over hypotenuse. Cosine is always adjacent over hypotenuse. And tangent is always opposite over adjacent. So we have those ratios that are super important. In order to remember that, somebody a long time ago came up with this. It's not really a mnemonic, because in a mnemonic you've got every word meaning something. Well, it kind of does. But it's sine, we'd say SOHCAHTOA. You might hear people say SOHCAHTOA. A lot of times they just write it as one long word, SOHCAHTOA, and it means nothing. It's a completely meaningless word. But it does help. SOHCAHTOA helps us to remember sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So when you're writing down and you're trying to figure these out, if you write this word on the side of your paper, it will help you with the opposite and the hypotenuse, adjacent, hypotenuse, opposite, adjacent, for finding what numbers go where. And let me show you what I mean with that. Because it's all well and good, we've got these letters, fantastic. But then you've got a right triangle. In your directions, it will say calculate the exact value of the trigonometric ratio for the right triangle. Exact. Write that down. It's your third keyword. When they want the exact value, that means that you're going to write it in fraction form. You are not turning it into a decimal. You are going to reduce that fraction, and you're going to handle any square roots as they need to be handled. Okay? So we're going to be thinking through this idea of SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. If you get tired of hearing me say that, good, because then you're going to get used to it. Okay? Make it into a song that never ends or something like that. But opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So I look at my sine, and I'm basing these things off of A. So I need to look at angle A, and my first step is always going to be to identify where the opposite and the adjacent and the hypotenuse live on this right triangle. Easiest one to do is hypotenuse. Find your hypotenuse. Okay, my hypotenuse is 12. My opposite side is the one that's furthest away from it. So here's my opposite. And that would leave the other one to be the adjacent one. And even if you feel silly making these labels are helpful, okay? Because once you have opposite and you have adjacent and you have the hypotenuse, you can use SOHCAHTOA. You can use sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So opposite over hypotenuse is 3 square root of 7 over 12. Now, we have a fraction that can be reduced. The square root of 7, you can't get anything out of that, but you can reduce 3 and 12. Because divide by 3, and you get 1 and 4. So this, whatever number of degrees this is, the sine of that value is the square root of 7 over 4. This is your exact answer. The cosine for this one, adjacent over hypotenuse. The number of the adjacent is 9 and the hypotenuse is 12. Reduce your fraction. Divided by 3, divided by 3. Notice we have not used the calculator yet. Remember, the calculator comes Tuesday next week. Tangent, opposite over adjacent, opposite over adjacent. 3 square root of 7 over 9. These labels make it super easy. Look for things to reduce. The 3 and 9 can reduce to 1 and 3, and you end up with the square root of 7 over 3. This is your answer. That is your trig ratio for these different values. Okay, let's do this again. Oh wait, that's the same triangle. Yes, it is. It's the same triangle. But notice now we're looking for the sine of B and the cosine of B and the tangent of B. So you need to relabel your opposite and your adjacent and your hypotenuse. It's the same picture, yes. Our hypotenuse is still 12. But now because we're working off of B, the opposite is 9. And the adjacent is 3 square root 7. So please write down that your next keyword is ratio. Okay, so your next keyword is ratio. So here we have our sine of B being opposite over hypotenuse. Opposite is 9, hypotenuse is 12. That can be reduced to 3/4. Easy breezy. Cosine of B is adjacent over hypotenuse. The adjacent side for B is 3 square root of 7, hypotenuse is 12. That can be reduced. Square root of 7 over 4. The one that gets tricky here is the tangent of B, opposite over adjacent. And if you recall, we don't like to have a square root in the denominator. So since we don't like to have a square root in the denominator, we need to fix it. I want to multiply the numerator and denominator by the square root of 7 over the square root of 7. Wait, something else changed. What else changed? The other thing that changed is the 9 and 3. They can cancel out. So the 9 and 3 cancel, gives you a 3. We have this nasty square root 7 in the denominator. We need to get rid of it. We multiply by square root 7 over square root 7. The numerator is 3 square root of 7. The denominator is just 7. We had dealt with this when we were looking at your special right triangles with the getting the square root out of the denominator. So hopefully it's had a few more months to sink in. So you have got that. Okay. So let's take a look here. We want to find the exact value. Exact value means that you're going to be able to do this mostly by hand and you'll be able to do your calculations. Sine, cosine, and tangent of G. Well, that's great, but we only have 2 numbers. And if we wanted to label them, we'd say, okay, I only have the opposite and the adjacent. What about the hypotenuse? So somehow, hopefully, it's triggering in your mind that we have a way to find that hypotenuse. And that's by the Pythagorean theorem. A squared plus b squared equals c squared. 6 squared plus 10 squared. Notice I gave it a little f because it's across from the capital F. 6 squared plus 10 squared equals f squared. 36 plus 100 equals f squared. 136 equals f squared. When I try to square root 136, I do not get a whole number. So what I need to do is I need to simplify it. It said exact answer, so we don't want to get our decimal approximation. We want to factor 136, 2 and 68, and 2 and 34, and 2 and 17. Remember, you can look for pairs. Here's my factored form. There's a pair of 2's, so 1 can come out. And so f is 2 times the square root of 34. Now I have my hypotenuse. So you can label, okay, our labels. This is our hypotenuse. If it's going to let me, if it won't, I'll just type it in. They can't beat me. This is my hypotenuse. So this is my hypotenuse. If it's going to let me write. Okay, so our hypotenuse is right here. These are not the keywords, by the way. It's just it wasn't letting me write. So hypotenuse across from the G is the opposite side. And this one over here that's left over has to be the adjacent. The adjacent side means next to. Next to the hypotenuse makes the angle. So our sine is the opposite over the hypotenuse. 6 over 2 square root of 34. The 6 and the 2 can cancel out. They're both divisible by 2. So that gives you 3 over the square root of 34. We don't like the square root of 34 in the denominator. So multiply by square root of 34 over square root of 34. The numerator is 3 square root of 34 and the denominator is the square root of 34. A square root times itself gives you the number. Some of you have started to see a pattern. If you know it by pattern, that's great. Okay? But I'm going to show it over and over and over again, and I want you to do it this way until you are able to do certain things. If you can figure it out in your head, but it's so new to you, please write it all out. Cosine is adjacent over hypotenuse. 10 over 2 square root of 34. The 2 and the 10 can reduce to 5. Once again, we have to get rid of square root of 34. So we do this. This is just a 1. So we get 5 square root of 34 in the numerator and plain old 34 in the denominator. Tangent will be our easiest thing to do. Tangent is opposite over adjacent. 6 over 10. 6 over 10 reduces to 3/5. So the problems that say exact value, you are set up to do the first little bit of problems in the assignment. I need this to sink in. So you need to make sure that you have your notes, go over it, make sure you understand it. Do the first little bit of problems so that this will be sealed in your mind and you can do it. And when we pick up with the lesson on Tuesday, you're going to be able to follow along just fine. Okay? Thank you very much. Have a very, very blessed day and a very wonderful Memorial Day weekend. God bless you.